Hello everyone. Today we are in module 5 of VLSI design of 6th semester ATRX branch. Now the module 5 chapter name is data path designing. In this chapter we are going to see binary adders. So normally we know that there are two types of adder, half adder and full adder. So we are going to see implementation of adder, half adder and full adder in CMOS circuits in this lecture. So now we'll start with the half adder. So now we know that half adder is going to have a two inputs which is used to add two single bit binary numbers. So we can see here half adder will consist of two inputs A and B and the two outputs sum and carry. Now based on this two input combination, the sum and carry will be generated. So the same thing can be seen in the truth table. So here in truth table A and B are the two inputs and the sum and carry are the two outputs. So we have here the default combination I have written, so 0 0 0 1 1 0 and 1 1. So when A and B both are 0, sum is 0, carry is also 0 because there is nothing to add. When A and B is 0 1, so sum is 0 plus 1 is 1, carry is 0. When A is 1, B is 0, so 1 plus 0 is 1, carry is 0. And when both A and B are 1 1, then the sum is going to be 0 because 1 plus 1 is sum is 0, carry generated 1. Now we have to implement this truth table in the equation form, or we can say we can implement this truth table in the circuit. So we have to make the circuit by using the equation. So we have to find out the Boolean equation which can be obtained by using K-map. So by K-map simplification, now here we can see that the input is 2, so the K-map will be 2 variable in K-map. So here we can see here A and B are the two inputs. The combination is written 0 1 0 1. Same way for the carry also, A and B are two inputs, 0 1 0 1. Now we are going to write the sum table output values in this value. So we can see 0 1 1 0, so 0 1 1 0. Same way carry 0 0 0 1. Now we have to perform the grouping. So here we can see that this one and this one cannot be grouped together, so they should be grouped individually. Same way here only one is there, so we have to group individually. So the grouping for this one will be A, because here it is 1, and B is 0, so A into B bar, and for this it is A bar into B. So here I have written, so A bar into B plus A into B bar. Now this equation also indicates the XOR operation, because if you see this equation, it is similar to XOR operation. Now for carry only 1 1 is there, so the combination will be A into B. So here it is AB. Now the same thing, the same equation can be implemented in basic gates. So here we are going to use XOR gate, so the two inputs will be A and B, the sum is output, and the one AND gate, because here we can see that A and B are the multiplications, so we are going to use AND gate. So A and B are the two inputs, output is carry. Now we have to implement this equation in CMOS, because we are in the VLSI design subject. We have to implement everything in a CMOS circuit. So we have, for implementation in CMOS, we know that CMOS output is an inverted output. CMOS output is a inverted output. So we have to write this equation in an inverted form. So how it is possible? So to implement in CMOS, the equation of S and C should be complemented, as output of inverter is complemented. So by taking double bar, so how it is possible? So we can take double bar on both the equations. So by taking double bar on S and C and solving by De Morgan's principle. So here we can see that S is equal to A bar B plus AB bar double bar, and C equal to A into B double bar. Now we know the De Morgan's principle. If you are having some problem in De Morgan's principle, so we can see how the De Morgan principle works, is that A plus B bar is equal to A bar into B bar. That is the De Morgan principle 1, and A into B bar is equal to A bar plus B bar. So by that principle, so A bar into B bar, the plus sign will change to into A into B bar bar, and single bar is always there. Here A into B bar will return as A bar plus B bar, and 1 bar will be there. So this again can be simplified. So here A bar, so here this can be written as A double bar plus B bar. So A double bar is A plus B bar into A bar plus B double bar. So B double bar is B, the whole bar. This will remain as it is. Now we have to implement this equation in CMOS. Now we know that CMOS consists of NMOS and PMOS both. Now the NMOS will, in the NMOS circuit, if the equations, if the two inputs or the inputs are written in terms of plus form, so this will come in parallel combination, while into will come as series combination. Same way these two will come in parallel combination, correct? And PMOS, it is the dual of the NMOS, means we have to invert. So input into will be drawn as the plus, that is parallel, and plus will be drawn as a series. Same way for the carry. So here I am going to draw the sum and carry output for the CMOS circuit of half adder, circuit diagram for the half adder. So we can start with the first is A and B are in parallel. So here we can see, so I'm taking A, then B bar, so this will be A bar and B. Output is grounded, so this is your NMOS circuit. Now the combination output will be coming out as sum, and PMOS, this A and B bar will come in series and this will come in parallel. So here we can see here in series combination, so for your NMOS you have to put, PMOS for you have to put bubble. So this A and B bar, so A and B bar in series. Same way here also you have to implement A bar and B. Now this combination will be connected to this one, and here VDD will come. So this is your sum circuit for half adder. Now same way we can draw for carry also. Now for carry, we know that there are two inputs, A bar and B bar. They are in plus sign, so obviously the NMOS will come in series combination, parallel combination, while PMOS will come in series combination. So here, so I'm drawing in parallel combination the A bar and B bar. A bar, B bar, here it is grounded, the output is carry. Now we know in PMOS it is in series combination, so we have to connect two PMOSes in a series combination to the output. So it is A bar and B bar, and the supply is VDD. The output is carry. So this is a circuit diagram for CMOS implementation of half adder. Now if you see, we can implement this, but the problem with the half adder is that if suppose in between, suppose if you want to add, for example we'll understand this disadvantage of half adder. Suppose A is somewhat is like 0 1 1 1 0, and your B is somewhat like 1 0 1 1 0. So if you perform the addition here by using half adder, so 0 plus 0 is 0, 1 plus 1 will be coming 0, your carry is going to be 1. Now we know that in the next bit operation this carry should be added in this operation, but by using half adder, if you want to implement this addition, this carry will be not added, it is discarded. So means what? Half adder cannot be used for addition of 2 bits properly. So to overcome these problems, full adders are used, because in full adders we are going to have a third input, which is your carry input, so where this carry can be taken care of to perform the addition in the next bit operation. So we're going to see the full adder now. So full adder, if you see the circuit diagram, full adder, normally it consists of 3 inputs, A, B and the carry input, which is called Cin. Now it is used to perform addition, and it is a complete addition. We have seen with the previous example that we are in a half adder, there it is not taking the carry, it is not taking the carry which is generated in between. So that addition, that carry should be added. So the full adder takes that problem. So 2 inputs. So full adder, if you see, it is consisting of A, B and C in the 3 inputs. Sum and out, C out is the 2 outputs. Now here, if you see the truth table, so A, B and C in are the inputs, S and C out is the output. Now I have written here default input combination for 3 by 3 inputs, so obviously there will be 8 combinations, so 0 0 0 0 0 1, like that way we have to write all the 8 combination. Now we start with the performance of addition or addition operation. So 0 plus 0 plus 0, his sum is 0, C out is 0 because there is no 1 coming. 0 plus 0 0, 0 plus 1 1, sum is 1, C out is 0. Then 0 plus 1 1, 1 plus 0 1, sum is 1, carry is 0. 0 plus 1 1 and 1 plus 1 0, so sum is 0, carry is 1. Then 1 plus 0 1, 1 plus 0 1, so sum is 1, carry is 0. 1 plus 0 1 and 1 plus 1 is sum is 0, carry is generated 1. 1 plus 1 0, sum is 0, carry is 1, and 0 plus 0 0, carry is already correct, generated 1. So 1 plus 1, carry is 1, sum is 0, 0 plus 1 1, carry is 1. So in the last bit we can say when all the inputs are 3, the sum and carry both are 1 1. Same way how we have implemented half adder, we have to implement full adder by using Boolean equations. So that can be done by solving the K-map. So here I have solved it. So if you see the K-map properly, so it is 3 inputs variable because A, B and C in. So A is written here, B and C in here. Same way here for carry also, A and B, C in. Now the input combination 0 1, so 0 1 2 3 4 5 6 7. This is the combination we have to write. So we have to write for sum, so 0 1 2 3, so 0 1 2 3 4 5 6 7. Same way for C out, so 0 0 0 0 1 0 1 1 1. Now if we now we have to write down the equation for that. So for writing the equation we have to see the combination or the grouping. Now if you see properly here, we can't group anyone because they are present in some different positions, so grouping is not possible here. So this one will be separate, same way, but here the grouping is possible, so we can perform the grouping of these two ones, then grouping of these two ones, and grouping of these two ones, because we know that the grouping is always taking place in the even numbers. We can't have odd numbers one group together. So the output for this bit is A, B bar, C in bar. Then for this bit one is A bar, B bar, C in, and for this it is A, B, C in, which is this one, and for this one it is A bar, B, C in bar. Okay, here the grouping is there. So for this grouping the output is, so we can see here B and C in, because the A is changing, so it will not come, so B into C in. For this grouping it is A into what is common between these two, it is C in, so A into C in, and for this grouping A into what is common, B is common, so this B. Now we can implement this by using simple boolean or simple gates, but we are not going to implement that because it is not useful here. We have to implement this in terms of CMOS. So we know that to implement in CMOS we have to write down these sum and Cout equation in terms of complement form. So to write down in the complement form, we have to take the double bar, how we have taken for the half adder. So we will take the double bar of that. So for taking double bar, obviously we have to write down the equation. So sum is equal to A into B bar C in bar plus A bar B bar C in plus A B C in plus A bar B C in bar. Now when you take a double bar of that, one bar will come inside. So we know that when one bar comes inside, this plus sign will change to multiplication sign and individual bars will come. So A B bar C in bar into A bar B bar C in bar into A B C in bar into A bar B C in bar, the whole bar. Now this individual bar can also be split up in terms of addition. So A plus A bar plus B plus C in into A plus B plus C in bar into A bar plus B bar plus C in bar into A plus B bar plus C in, not bar, so no bar will come and the simple whole bar will come. So this is the output equation for sum. Same way we have to go for carry. So carry I'll write here. So Cout is equal to, if you see the equation, it is consisting of B into C in plus A into C in plus AB. So B into C in plus A into C in plus AB double bar. So when you take single bar out, so B into C in bar into will come A into C in bar into AB bar, the single bar. Now we can break this double bar also. So it is B bar plus C in bar into A bar plus C in bar into A bar plus B bar by De Morgan's principle, and the bar will come. Now we have to implement these equations. So this is Cout and this sum will be equal to some equations will be, we have written some equation as, can write A plus B plus C in bar one bracket into A bar plus B plus C in one bracket into A plus B bar plus C in one bracket, and the other bracket is all bars plus C in bar. So we have to implement this C sum and C carry in a CMOS. So we know in CMOS there should be one NMOS and one NMOS combination and one PMOS combination grouping will be there. So how the grouping can be taken place, so we'll draw that. So first I'll draw for NMOS. So we can see here for sum these are all input, so obviously these are all multiplication, this will come in series, while these are all three will come in parallel. So in series we have to draw them. So how to perform in series? So actually first we'll draw these in parallel, so in series will come. So I'll draw here. So in parallel we will draw them. A here, so we'll draw on the new, or it's okay, we'll draw here only. Actually it will not come here, so I'll draw on a fresh page. So we require these equations, and I'll draw the equation here. So here if you see, the equation will be A, B, C in bar, A bar plus B plus C in A plus B bar plus C in, and the third one is the complement of all the three. This will be grounded together. So here it is, A bar, B bar and plus C in bar. So this is for NMOS, and now similarly we'll go for PMOS. So obviously this is your sum output. Now for implementation P bar, we know that this A, B and C in which are in parallel, obviously they will go in series. So when they are in parallel, so we have to, obviously they are coming in series, so we'll short this terminal. So what will happen, they will become in parallel, otherwise they will be in series only, so we have to short these connections. So now they will be in parallel. Now this A, B and C will come in series, and this series will come in parallel. So here four parallels, or four we can see four connections will be there which will come in parallel. So we'll draw one by one. 1, 2, 3. Same way, 1, 2, 3. Here 1, 2, 3 and 1, 2, 3. Now this all group together, they are connected to the output. This is your VDD. Now here this is PMOS, so obviously we have to bubble it. Now, so which are with the in NMOS, which are the inputs which are in parallel, they will come in series. So A, B, C in bar. So here it is A, B and C in bar. Then A bar, B, C in. So A bar, B, C in. Then A, B bar, C in. So A, B bar, C in, and then all the three bars. So A bar, B bar, C in bar. So this is the sum output which we can get from the CMOS circuit. Now we have to implement the carry. So same way we can implement the carry. So for implementation carry, again here these are in parallel, these are in parallel, these are in parallel, and all the things are in series. So here I am going to implement that in parallel. for to be in parallel, this should be shorter, so these two are coming in parallel. A bar, B bar, B bar, C in bar, A bar, C in bar. Okay, the output here is carry. Now we know this should be in PMOS, these two will be in series and this series will be in parallel. So here we have to connect 3 parallels. This is VDD. Now we are going for PMOS, so obviously this A bar and B bar, then B bar and C in bar, and then A bar and C in bar. So this way we can implement the full adder and half adder in CMOS. Thank you for listening.